Final multivibrator that we're looking at is called the A-stable multivibrator. It's called A-stable because it has no stable states. It's also called the free running oscillator, and it's typically used to operate timing devices or to keep track of pulses. Circuit diagram for the 555. We have a positive supply that connects to my 555 IC through pin number 8. I also connect pin number 4, which is the reset, to ensure that it doesn't automatically reset, and pin number 1 is going to connect to my 0 volt supply. Pin number 3 is my output. Pin 7 and pin 6, pin 2, pin 7 and pin 6 connects to a connection point between a resistor and a capacitor, and then pin number 7, let's draw it up over there, pin 2 and pin 6. Pin 7 is going to connect through a resistor to the positive supply. Let's label these quickly: R1, R2, C1. Okay, now remember, when my output over here is 0, then pin 7 connects to pin 1, and the capacitor voltage will be 0, or will connect to 0 through pin 7. When I've got 1 on the output, then I've got a disconnect and the capacitor can charge up in voltage. So during a 0 on the output, my capacitor discharges, and during a 1 or a positive supply on the output, my capacitor will be allowed to charge. Now we're going to look at two inputs at this point in time. We're going to look at the output voltage, and we're going to compare that to what's happening on pin 2 and pin 6, which are my two inputs. So let's quickly draw a graph to show what is happening over here. Okay, my output over here can be positive supply voltage or 0 volts. So that is my output voltage over there. Pin number 2 and pin number 6 are my trigger and my threshold values. They both trigger at 1/3 and 2/3 of the supply voltage. If you guys recall, pin 2 triggers at 1/3 of the supply voltage, and pin 6 will trigger at 2/3 of the supply voltage. So this is for pin 6, and that is for pin 2. Okay, so let's accept the moment we connect this, we've got a high voltage on the output. That means, because I've got a high voltage, my capacitor is charging because pin 7 is disconnected from the supply. So what happens is my capacitor is going to charge. The voltage on the capacitor I'm drawing in red. So my capacitor is charging up at a rate set by the total sum of resistor 1 and 2. So it's going to charge, and once it reaches that 2/3 level, it is going to switch the output into the off state. And during the off state, we've got almost 0 volts on the output. Now during that time, the capacitor is going to discharge through resistor 2 to ground, and that is going to cause its voltage to decrease until it reaches 1/3 of the supply voltage. Once that happens, it's going to switch the output of the 555 back on, and it's going to allow the capacitor to start charging again to 2/3 of the supply. Once it reaches the 2/3 of the supply value, then it's going to trigger the output off again, and then the process is just going to repeat itself. It's very easy to remember this one because it has no contact or switching for the input. The entire process is controlled by the actual charging and discharging of the capacitor. Now if I want to calculate the time that this circuit is going to be on time is going to be equal to 0,693 multiplied by the sum of R1 plus R2 multiplied by C1, because the capacitor charges through both R1 and R2. That's the on time. To calculate the off time, I use the formula 0,693 multiplied by R2 multiplied by C1, because it only discharges through R2. If I want to calculate the period, in other words from the start to the end of one cycle, I could either calculate these two individually and add them together, or I can just simply say 0,693 multiplied by R1 plus 2 times R2 multiplied by C1, because during the charge I'm using R1 and 2, and during the discharge I'm just using R2, and that's why the 2R is there. To calculate the frequency, I could say frequency is equal to 1 over the period, or I can say the frequency is equal to 1,44. If we say that 1 divided by that, I get 1.44 divided by R1 plus 2R2, and I multiply that with C1 to give me my frequency. When it comes to the 741 A-stable circuit diagram, non-inverting, inverting, positive supply voltage, negative supply voltage, output voltage. Okay, my non-inverting feeds to ground through resistor, and we've got a feedback resistor which we are going to call R1. Let's call that one R2, and we can see because of the configuration we're going to have a reference voltage again set at that beta percentage R1 over R1 plus R2. My inverting input also gets a feedback resistor, which we're going to call RF, and it connects to ground through my capacitor in order to serve as timing. Now the voltage reference caused by R1 and R2 is equal to V out multiplied by beta, which is my voltage on the non-inverting input. Okay, V non-inverting. Okay, it's beta times output voltage. So my reference is determined by the relationship of those two resistors. Now I'm going to look at both inputs at the same time, and I'm going to compare that to what's happening on the output. So voltage on the inputs and my voltages on the output. Okay, let's accept that my output voltage is plus V, or positive saturation. That means that my reference voltage on my non-inverting input is also in the positive value. Okay. What now happens, let's get another color pen here, let's use red, is this capacitor is going to start charging. And once it reaches that value of the non-inverting input, it forces my output voltage to switch into minus V saturation, or the negative saturation. When that happens, my non-inverting, or the reference voltage, switches to the negative, minus V non-inverting, and it's going to stay there. That causes this capacitor to discharge and recharge at a rate set by RF, and that causes my graph to do that. Once it reaches that state, it forces my output to switch back to the positive supply voltage. Once it switches back to the positive supply voltage, my reference voltage again switches to positive reference, and once it switches to positive reference, my capacitor is allowed to discharge and recharge in the positive direction. You guys have to remember that because we've got a positive and a negative supply, we will have a 0 volt line over there and a 0 volt line over there. And that is the operation of the 741 op amp as an astable multivibrator. Oh, before I get there, if I want to calculate the period of this, I use the formula 2 RF times C1 log E 1 plus beta divided by 1 minus beta. Okay.